There's another paradigm called AOP, aspect-oriented programming. And what aspect-oriented programming is this is a programming paradigm that allows you to inject. So you can inject operations. You can inject operations in okay, I'm looking for the most plain way to define it. You can inject operations in non-specific code. What I mean by that is if we have a function, imagine you're working in an accounting firm and every month they do an audit of a specific account, or you have a program that goes into every account and does a general audit. So you have a function, okay, you have a function called audit that goes into every account and does audit. But when you're auditing accounts, there's some other things that you might want to do as well. You might want to log the account being audited. And your log might be going into like a very specific log file. So you have a log file for logging the accounts that your program was able to audit. Am I spelling audit incorrectly? There's E. Audited. That's being audited. Okay. Then you might want to, so you're logging the account being audited. You might want to log when the audit was completed. So the timestamp. So you want to collect a timestamp for timestamp. You want to collect a timestamp for when the audit, because the audit process might be a very long process. Imagine this is a client that has maybe 10 million employees and they have 50,000 branches and they have 1,000 suppliers. So your audit program will run through all the payroll data, all the supply and procurement data. It will basically take a long time to finish. So what you want to do is log the timestamp for when the audit was completed. Maybe you might also want to log the IP of the node. Imagine you have multiple instances of servers that are running this audit. You want to log the IP of the node that executed the audit. So which server was it? So that if ever you need to retrieve that data, you know which physical server to go to. Yeah, just imagining cases here. So here we have operation that should run before audit, which is log the account being audited. You have operations that should run after the audit function. And this one also IP of the node being, so this one is also a function that runs after the audit is executed. But also you might want to have some functions that run during the audit. Log the audit progress by timestamp. So when we get to auditing suppliers, log the timestamp where you started auditing suppliers. When we get to auditing sales, log the time that we started auditing the sales, so that if the audit process is interrupted, we know at which point it was interrupted and at what time. And maybe that might allow us to know who interrupted the process. So this might be executed during the audit function. So in the middle. So usually the way most developers would approach this is by adding those functions inside the audit. So most of this you can achieve by, if you have the, let's assume here we have a function public void audit that does the audit. To log most of this, you might just log maybe write the actual code log, and here you log starting audit at timestamp. We log the timestamp. during the audit, maybe you might want to log starting sales audit and include the timestamp. And after this is done, at the bottom, you might want to log finished auditing. And you might log the timestamp there as well. Timestamp. So this is how regularly as developers would probably achieve this. But let's imagine this audit operation is split into multiple functions inside your program. So you have a sales audit function. At the same time, within the same system, you have a procurement audit function. You have additional functions that all do this auditing operation. So if you wanted to do this logging function, you might need to duplicate all of that code into each of those functions. So instead of duplicating the code inside all the functions, of course, the next toolbox would be to use generics. You might use generics, but generics might not suffice for this. You might try to utilize inheritance, but inheritance might not work for it, because with inheritance, you still have to have, at the down level, there has to be like a class that now does the final implementation. So if it is code that is spread all over your code base, and for all those pieces of code, you want to do one common operation, and inheritance and generics doesn't solve that replication of operations for you, that's where AOP comes in. And AOP allows you to inject operations before, after, or during the execution of a particular function inside your code. What we'll do, you can imagine it like like middlemen. It is like a middleman in your program. Before a particular function is executed, it checks the signature of the function. If that signature matches a particular signature, it will do something before the function is executed. If it matches a signature, it might do something after the function is executed. So I guess with this, you guys can see what we are driving at. Let's see some documentation on this. So just look at the Wikipedia for AOP. Wikipedia. Okay, yeah, aspect-oriented programming. So in computing, aspect-oriented programming is a programming paradigm that aims to increase modularity by allowing separation of cross-cutting concerns. So cross-cutting concerns are those operations within your program that have to be executed in multiple places in your program. Logging is a good classic example of cross-cutting concerns. Logging, another cross-cutting concern could be authorization. So you want, before any function is executed, you want to check that the user that is trying to execute that function actually has permission to execute it. So that can also count as a cross-cutting concern. So it does so by adding behavior to existing code. So this is what I was referring to. As that behavior is called an advice. And even when you're actually doing the actual programming, you use this terminology, so it's important. So we're adding behavior into existing code without changing the code itself. So you won't be changing sales audit, you won't be changing procurement audit functions. Instead, you'll be embedding functionality in that piece of code without changing it. Yeah. So without modifying the code. Instead, separately specifying which code is modified via a point cut. So a point cut is the signature I was referring to. So you can tell it any function that ends with audit. If the name ends with audit, or it contains the word audit in it, if before it's executed, do XYZ. Or any class that starts with audit. Before any function event class is executed, do XYZ. So yeah, so that is the point cut. So we have advice, which is the thing that you want to, the procedure or the code that you want to inject inside that function. Point cut is how you distinguish which functions should actually adopt this procedure and which functions can be exempted. Such as log all function calls when the function name begins with set. So you can replace this set with audit in our case. So if the function begins with audit, eject this piece of code. So this allows behaviors that are not central to the business logic, such as logging, to be added to a program without cluttering the code. So instead of adding all these logging things inside all your audit functions, you can basically not have them inside the audit function, but they'll be injected into the audit function without modifying the audit function. Actually really beautiful. So just log in without cluttering the code or core functions. So yeah, so it includes some tools. In the Java ecosystem, now we can, okay, so there's some example here, sealed class, extend, start, permit, whatever. But I think we've gotten the gist of what should happen. So there's a library in Java called AspectJ. AspectJ is a library that allows us to implement aspect-oriented programming in the language. So you can see it's an aspect-oriented programming extension for the Java programming language created by those guys. Yeah. So we can use this as a library to do aspect-oriented programming. You can see it has ways of defining Pointcut. You can define advices and so on. So since we are in the Spring Boot ecosystem and with the Spring framework, Spring Boot, one thing you learn is that most of these libraries have wrappers. So you don't have to like do your own, basically make your own implementation. Spring Boot has some convenience APIs that allows you to do aspect-oriented programming without interacting with AspectJ directly. I would encourage you to read a lot of this literature if you're still not familiar with the AOP, so that when you're implementing it, at least you understand what's happening underneath. So within Spring, we don't need to use AOP directly. Instead, we'll be using this annotation called controller advice. And there are various annotations, but this is the most popular one, especially for our case, where we want to change the behavior of our controllers without changing our controller functions. So controller advice here, you can see it says, typically the exception handler model attribute method apply with the controller class, in which they do declare if you want such methods to apply more globally. So you can create a class, annotate it with controller advice, and within that class, you can have functions that do global operations like exception handling, which Steve was driving at. You can have init binder. You can have it do REST attributes, and also there's REST controller advice. So if I remember how this works is, so you have a class, you annotate it with controller advice. And once you annotate it, I don't think we even need to pass in this parameter. Once you annotate it with the controller advice, inside the class, you can have functions that use the exception handler annotation. I hope they've documented that there here. So let's just look at exception handler, because that's the one we'll be using to explain what Steve was driving at. So exception handler, the annotation. So basically, exception handler is a function that we can use to define within our controller advice. We can use it to define a function that acts as an advice, if you remove from the AOP documentation. And we can tell it to, whenever this particular error happens, intercept that function and inject this custom behavior. So you can see an example here, although this would normally be controller advice instead of controller. Exception handler, and then you specify the exception. And of course, now you have a function that should intercept that exception and handle it. Let's try and use this in practice. Anybody else who might want to explain that more clearly, or if I got anything wrong regarding AOP? Steve, do you want to catch us up on if there's a more simple explanation of what AOP is and how you implement it in Spring Boot? Or did you guys get my explanation? If somebody didn't know AOP, the way I explained it, would it be more clear? Patrick?
The way you have explained it is clear.
Oh, okay. Okay. Thanks for that vote of confidence. So if it's clear, then we can try and do an example here. So we can create an advice for our controller. So within this, we want to have a way to intercept any failures in processing any of these requests, in where we have what we are returning here as, so remember within HTTP there is internal server error. And with internal server error, we could catch we could respond to the client with the internal server error. If, for instance, we run into a null pointer exception, or maybe we run into a constraint validation exception where they pass some fields that don't match the values in our endpoint. So we can create an advice. And I hope I remember how this is done. So I'll just call this controller error handler. And I'll annotate this with at controller advice. And here, so once we annotate with this at controller advice, this will act as an advice. And we saw the definition of an advice. It's when the function is intercepted, what piece of code should be executed. So essentially, this means we'll be defining functions here that should intercept all our controller functions, regardless of which class they're in, and inject some additional functionality. And here, we can create a function that intercepts. So when it intercepts it, you have to also remember that at the end of the day, we have to return a response to the client, or at least we should. We should not leave the client hanging. So in all cases, we might need to still return a response entity. We don't know the value that will be returned to that as part of that, but remember we defined a generic response here. So we could just have that. I think I can get away with not specifying the type of the response body. But if this is an error and something goes wrong, we might probably want to, okay, let me leave it as that for now. So here I want to handle, let's say, null pointer exceptions. People usually use this to handle more sophisticated exceptions. So like a constant violation and so on. But let's say I want this to handle a null pointer exception. So we can annotate the method with exception handler. And this exception handler annotation just means that that particular advice will be able to intercept will be able to intercept the exception class that we've specified, and it will compose another response entity object and return that to the client. So if we look at the docs, they're saying annotation for handling exceptions in specific handler classes, like the one we made here. Handler methods which are annotated with this annotation are allowed to have very flexible signatures. They may have parameters of the following types. So you can include a session object, you can include a web request. So you can include multiple parameters for it. So for us, we will just include the throwable, which is the exception class that we want to handle. So here we can say this one handles null pointer exception.class. So that limits it to null pointer exceptions. And I think in the function we're supposed to pass in something, but what I also remember is, so whenever a null pointer exception, this function occurs, this function will intercept, and it will be able to return a custom response. So let's say we have NPE response here. Is equals to new response entity. And here we can specify the data is null in this case, and HTTP status is HTTP status code is so HTTP status is internal server error. So cannot resolve constructor. What am I missing? So I'm passing the data and the HTTP status code. Okay, it's HTTP status code instead of status. Okay. We can also do that, internal server error. So that will return the NPE response, and now we can return that as our response value for that. So there is the issue of the signature. So in this case, I'll try and not use that. Okay, so that is the build. I still need to do something here. Build. Okay, and then I can get rid of that. Okay, yeah, so with this, we should be able to intercept any exception class that matches the null pointer exception, and we'll be able to intercept it instead of handling that NPE within our controller function. So let's say one of these controller functions was throwing an NPE. I'm thinking of how to simulate that NPE. So if so let's see if I can simulate that NPE. So here we're passing in credentials. Okay, we could use this message one. Specify a string, some value, and that value could be the path variable. And then, so that is our path variable. The path variable is value. Then if value is equals to value dot is empty, then we throw a null pointer exception. So there'll be an NPE that will happen in this get message function, but we've not determined what the response entity will be. So what we are hoping is our controller advice will intercept that NPE, and it will return this internal server error. And to be sure, I should probably have more information in that. So let me just change the response entity so that we have a string, so that we can inject something custom that allows us to know what's happening. So in the body, I'll specify so request failed, experienced a null exception. Maybe tell the client ensure value is not empty. Null pointer exception, ensure value is not empty. And I think we can return that as the response, or at least attempt to. Because what we are hoping is this handle null pointer exception function will be called without us calling it explicitly in this get message function. So we can go to our controller test and we run it. So we see we sent the message. We didn't pass in the path variable, which is that value. And okay, that gives me a 404 because the path variable forms part of the signature. I should have used params. Okay, I'll just pass a blank path variable. Okay, can't pass a blank value here. How do we test this? It's actually here. I have to use parameters. Let me pass something like test. And on our side here, allow me to, because our time has really went past, I'll try to just have like a rudimentary example so that we just see this interception thing. Content equals. So here what I'm doing is if the content equals test, I'm throwing an NPE. Just to see whether the NPE will be intercepted. Okay, so so we sent that with /test, which means that there's a valid test. Status is 500, and you can see request failed, null pointer exception, ensure value is not empty. So essentially, we were able. This function was executed without us calling it in our controller. We're able to intercept the point at which that null pointer exception occurred, and we injected our own code into it. So here maybe you can say ensure value is not test. It's not test. And if we run that, the API will be communicating that if the value is test, we throw a null pointer exception. And here we can see that custom message is included. So here you can do some more interesting things, like if a particular error happens, you might want to log it. You might want to call some other service that does something else. You might want to call the police, whatever. But that function of logging or calling the police will not be part of your controller function. It will be some other AOP thing, an advice that is isolated from your controllers. Your controllers remain clean, but the advices can still come in and intercept execution.